dive into the heart of TypeScript, defining the structure of objects using interfaces and type aliases. Interfaces in TypeScript are powerful. They allow you to define the shape of an object, including the types of its properties and the functions it must implement. Consider an interface named person. This interface requires a name of type string, an age of type number, and a greet function. When you create a person object, TypeScript checks to ensure it fits this structure. Here's how it looks. Imagine defining a person like Alice, 30 years old, who greets you with a cheerful "Hello." Through TypeScript, you ensure that every person object adheres to this predefined structure, making your code predictable and error-resistant. On the flip side, type aliases serve a similar purpose but are more flexible. They can represent not just object shapes but also unions and intersections of types. For example, define a car type alias specifying brand, model, and year. When you create a car object, such as a 2020 Toyota Corolla, TypeScript ensures it matches the type alias's structure. Creating objects in TypeScript can be straightforward. You can directly assign values to variables defined with a type or interface. Think of a book titled TypeScript Basics by John Doe with 200 pages. By defining it directly, you maintain clarity and enforce structure. For more complex scenarios, classes come into play. They provide blueprints for objects, incorporating constructors and methods. For instance, an animal class might define a constructor for name and species, and a method to make a sound. Creating a dog named Buddy then becomes a structured, error-checked process. Working with these objects is intuitive. Accessing and modifying properties or calling methods is done with simple dot notation. Whether updating an email address or making a smartphone ring, TypeScript structure keeps your interactions straightforward and type-safe. Moreover, TypeScript supports advanced features like optional and read-only properties, enhancing flexibility and control. Optional properties allow for undefined values, useful in scenarios like employee records where some information might be unavailable. Read-only properties, on the other hand, ensure some values remain unchanged after their initial definition, critical for maintaining integrity in applications. Finally, index signatures in TypeScript add another layer of flexibility, enabling objects with dynamic property names. This is particularly useful for dictionaries where keys and values can vary. In conclusion, TypeScript's capabilities for creating and managing objects through types, interfaces, and classes provide a robust framework for developers. This structure not only facilitates type checking, but also enhances code maintainability. By defining the shape of objects, TypeScript empowers developers to write clearer, more reliable code. So, consider incorporating TypeScript objects in your projects and explore its potential to streamline your development process.